Design is not just what it looks like and feel like. Design is how it works. Welcome to this video presentation. I am Martin Premkumar doing my final year BE Mechanical Engineering in Loyola ICAM College of Engineering and Technology. In this video, I am going to present how to design a gear train using Autodesk Inventor software. I learned to design gear train using Inventor software by enrolling in an online course offered by Skyfi Education Labs Private Limited. Before starting with Inventor software, let us see a video clipping to understand the working of gear train. The principle behind the functioning of this machine is when the machine is pushed forward, the conveyor belt placed at the center is moved backwards towards the garbage collecting box. We will have a question in our mind that how a conveyor belt direction is reversed as the machine moves forward. It was reversed by a simple gear train system. Sometimes two or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called as gear train. Here is the construction of gear train mechanism. In the left part of the slide, we could see four bearings attached to both sides of the structure of the machine. The use of bearings is to increase the efficacy of the shaft rotation. The shafts are attached through the bearings. The gears are attached to the shaft by means of a keyring. Thus, when the upper gear drives forward, the lower gear attached to the conveyor belt moves in the reverse direction. From this explanation, we can understand the working of gear train. In order to design a gear train system, first we need to design a bearing housing. To design a bearing housing, click on Part option available. The part window appears on the screen. Go to File, Save As and save it as bearing housing. Thus the part name is saved. Now click the Tools tab to check for units. Go to Document Settings. Click on Units and change it to SI System. Click OK. Now go to Sketch, click on 2D Sketch. Select YZ plane and YZ plane appears on the screen. Click on Rectangle option. 2-point center rectangle is selected. Click it and drag it from the origin. Set the dimensions, width as 400 mm and height as 150 mm. Place 2 circles on the rectangle. Now set the dimensions of circle 75 mm diameter each. Set the distance between the centers of the circle as 180 mm. Now trim it to get a two-dimensional view of a bearing housing. Now click on 3D model, click Extrude command. A dialog box appears on the screen. Set the distance as 20 mm and click on Symmetry option. Now click on Fillet icon available in the 3D model. Select the mode as edge and the radius of fillet as 20 mm. Select the edges and click OK. Thus we have achieved designing a bearing housing using Autodesk Inventor software. Next we need to design spur gears for gear train. Click File, Assembly. Assembly window appears on the screen. Go to File, Save As and save it as gear train system. Next click on Tools tab, Document Settings, change the units to SI system. Now click on Design tab where we can find icons of shafts, spur gears, keys and bearings. First select spur gear icon. A dialog box appears on the screen with the following data. Before that, we will see what all the data which has to be added. The gear ratio is 2:1. The power to be transmitted is 3.5 kilowatt. The speed is 120 rpm. The center distance between the gear and the pinion is 180 millimeters. Enter these values in the dialog box. Click on Calculate tab where we can enter the power and speed for gear 1. When we enter the values for gear 1, the values for gear 2 automatically changes. Finally, click on Calculate tab at the bottom to find whether our design is safe or not. Click on Calculate tab. You could find calculation indicates design compliance. That means our design is safe. Now spur gear 1 and 2 will be generated on the screen. Thus we have designed spur gears for gear 10. Next we need to design shafts for gear and pinion. First we will design shaft for gear. The shafts contain of 5 sections. The center section should be the largest part and fix it as 128 mm and length as 100 mm. Click OK. The shaft will appear on the screen. Next we need to design shaft for pinion. The center part of the shaft has to be changed for pinion. Change the diameter as 56 mm instead of 128 mm. Click OK. Shaft for pinion is designed. Now we need to mate both these shafts to gear and pinion respectively. Click on Constraint option, choose section 1 and choose the cylindrical section and go to gear option, the left end of the screen, and select the axis as Z axis. One part of mating is over. Now we need to fix the shaft to the gear. Click Constraint option again and choose the face of the gear and the inner radius of the shaft and enter the offset value as 30 mm. Thus the shaft is fixed to the gear. Now we need to fix the another shaft to the pinion. The same procedure is followed. The direction of shaft should not be in the same way as of the gear. So we need to change the direction of shaft for both gear and pinion. The offset value for both the shaft should be similar. So enter the offset value as 30 mm. Thus we have designed shafts and mated it to the spur gears. Next, we need to design keyways. Click on Keys icon. A dialog box appears on the screen. Click on Reference 1. It asks us to select the cylindrical face as reference 1. Click on Reference 2. It asks us to select the planar face. Select the planar face. Click on Reference 1 for hub groove. Select the planar face. Finally, select the circular edge of the work point. Zoom it and select the circular edge. We can find the keyway appearing on the screen. Spread it equally between the center of the shaft and click OK. A keyway will be generated between the gear and the shaft. Using the similar procedure, we need to create key between the pinion and its shaft. Make sure the keyway does not go out of the shaft. Thus, we have created keyways between the gear and its shaft and pinion and its shaft. Next, we need to design bearings. Enter the range as 18 to 22 mm. Select all bearings option and standard as JIS. Click on the following standard in order to achieve proper dimension for bearings and the shaft. Click OK. Now we have designed a bearing. Since we need 4 bearings, click Copy option and paste 3 other bearings. Now we need to mate these bearings to the shafts. Click on Constraint icon. Select the section 1 to be the inner diameter of the bearing and the outer surface of the shaft. Click OK. The part of mating is over. Now click the outer surface of the bearing to the outer surface of the shaft. The outer face is selected. So the mating for one part of the shaft is over. Now we need to mate other three bearings to other three sides. Make sure the bearing is movable. Follow the same procedure to mate other three bearings to the shafts. Thus, we have mated four bearings to four sides of the shaft. Next, finally, we need to assemble the bearing housing to this assembly. Place two bearing housing and drag it and position it to a proper orientation so that mating becomes easier. Click on constraint icon. Place the cursor to the bearing housing. Click on axis option. Place the cursor to the shaft. Click on axis option. One part of mating is over. Now again click on constraint icon. Click the face to be mated and click on the face of the bearing. Now finally click on constraint. Click the face of the larger part of the shaft and the face of the bearing housing. Click OK. One side of the bearing housing is mated to the shaft and its other assembly. Similar procedure is followed to mate the other side of bearing housing. By following the similar procedure, we will achieve the assembly of gate train system. Thus, we have designed the complete assembly of the gear train using Autodesk Inventor software. This course, which I have enrolled through Skyfi Lab, gave me a good hands-on experience on the Autodesk Inventor software. I obtained good design knowledge about the gear train. I thank Skyfi Lab Private Limited for providing me this excellent opportunity. I thank the management of Lizard, especially the faculties of Mechanical Department, for their continuous motivation and timely updation about different online courses available during these quarantine days. Thanks for watching.